We're going to build an airplane. Okay, so yeah. So we're going to pretend we're going to role play that we're at Clear Lake Space Center, back in Houston, and we're sitting in one of the NASA buildings, and they're talking about how we need to build an airplane. And of course, like all good companies, they put a production team together, and everybody's got their own little interest in mind. Okay, so the economics guy, he's going to be worried about, okay, well, how much is this going to cost? And then the aerodynamics guy is like, well, I want the fastest thing out there. And then you're going to have the payload guy who's like, okay, well, I want all my weapons on it, and so on and so forth. So it's going to pretty much, and I think once we go through this exercise, we'll see pretty much how a simple idea of building an aircraft can kind of turn into something a little bit crazier. So, okay, let's go ahead and let me get a volunteer. All right, so you right there, come on up. And what we're going to do is we're just going to start piecing an airplane together. So we don't know what the body's going to look like. Well, actually, you start with the body. Okay, so just the fuselage. Don't put wings on it. Don't put a propeller on it. Just draw us a general shape, top-down view, how you think an airplane would look. And we're going to build this airplane. Everybody's got their own idea. So let's just go ahead and build. Just build me a body. All right, good deal. There you go. All right, so top-down view. And which ones are front? The front's the top. Top of it is the front, and the back. Bottom of it's the back. Okay, yeah. Okay, we'll work with it. Okay, let me get another volunteer. All right. We need wings on this. All right. So go ahead and draw me some wings. How do you think an airplane should look? All right. Now maybe you got your own idea how this airplane should run. So go ahead and put your impersonation on it. What you think the wings would look like?
Fast Learjet.
Yeah, good deal.
So good at something.
Yeah, okay. See, so we're on improvement already. It's looking a little bit better. Okay, come on up.
Okay.
Go ahead and draw the bottom part of the airplane, or the back part, the empennage. And you know what? Let's use a different color. Let's go ahead and use one of those reds right there. Let's use different colors to differentiate different parts of the aircraft.
I don't know why. I picked you rules.
Okay. Going for an early Blériot model right there.
Yes.
No problem. Okay. All right. Good deal. So we got it generally taking shape right now. Everybody's got their own idea what they want it to be. Okay. We need engines. Go and put some engines on this thing.
All right. What color?
Go ahead and use green. That's right. That's it. Right.
All right. Turbine.
More like eyes.
Looks like a face.
Yeah, it does look like a face. It's like a huge plane with small engines.
Yeah,
Or
put
huge
two on
nose
each wing.
with small eyes.
Two.
Yeah.
Go ahead and put a
Please.
double
Now
better
you're
note.
in the face. Are you going sideways?
Yes.
Like
Shut up, don't judge me.
You don't have to
They're
put too
both
much thought into it. Just go ahead and slap something up there.
Alright.
Basically, all we're doing is we're just drawing a paper napkin right
the
now.
plane is like going like this when it takes off.
Don't judge me. Maybe it's a thrust vectoring engine. Maybe the engine's a tilt on the wing, on the other side of the wing.
See that one terribly
It's a
well.
beautiful plane, and I'm sure it could do it.
Okay, so
One
we
blocking that way,
can't
one
let the
blocking
thing
that
piece
way.
apart.
Ripping the fan apart.
There you go. Okay, so we got wings, we got engines, we got
Looks like a beaver tail.
wow.
Oh, wait.
That's what that looks like.
Oh, wait.
That tail fin right there.
Looks like a
The one that's sticking out on the right.
It looks like a Boeing 747 that got stuck
Right.
into a pencil.
So tell me, what do you think about this plane? What do you think its mission would be? What do you think if you saw a plane like this? Well, what do you think?
Crash.
Cargo? Who said cargo?
I-
Okay, why do you think it would be a cargo plane?
Because it has,
I think it's a target.
it has 2 engines on each wing. So
Okay, so what is this?
And it's fuselage.
So cargo, and why do you say that? Because
It's a really big fuselage and it has 2 engines on each wing.
okay, so it's a really big fuselage, and it's got 2 engines on each wing. So it's a big fuselage or big body basically, AGE, and then basically 1 times 4 engines. Or I could just put it 4 engines. Alright. So 4 engines. Okay, so yeah, so you look at it and be like, okay, so there's engines on it, so it's either going to go very fast or it's going to carry a lot of cargo around, or a lot of people. Well, we call that self-loading baggage, you know, generally what we call people. Right, so, and then you get the idea that it's kind of a big body, okay? So, all right, who else would think that, what do you think this plane would be good for?
I was thinking cargo.
Cargo? Anybody else besides cargo?
Yes.
I guess if it's a small plane, it could be made for speed.
Okay, and what would make you think that it would be built for speed?
4 engines and the aerodynamics.
Okay, and what do you think, what out here?
Look, I'm just thinking about it, like, look at the front of it. I mean, it's not exactly blocking the
And then the
wind.
back's like a parachute.
And then you also have the 4 engines and the tail, I mean, are obviously flat. So I really...
Okay, so you're saying the general shape of these wings right here would make you think it's built for speed,
Yeah.
basically.
Just
The delta design right there, the delta wing. Okay, yeah, it does kind of look like that. It kind of looks like it started off on one idea and then it kind of convoluted into another idea, and then this is the kind of the finished product. Like, whoa, we didn't see that coming. Which actually probably happens a lot more often than you think, but that was So your airplane's going to have distinct parts to it. The whole point of this exercise right here, and we'll do future iterations of this, and it'll get a little bit more complex, and I'll actually give y'all like mission objectives. And don't be surprised if you see a question on a test like, okay, you are an engineer, you're tasked to build a ship and put these following factors into consideration. But
Then we'll have to draw an airplane on there.
yeah, I mean, you know, just a little.
Always wanted to draw there.
Just a little thing. Yeah, well, you'll be able to draw one on the test.
Yeah, you can draw more beaver tails.
But okay, but generally the whole purpose of this exercise is to show you, just kind of get you guys thinking that you need to think of an airplane not in a singular unit, not as, okay, well, you see an airplane, it's sitting out there, it's a big piece of equipment, and it's all kind of blends in. What you want to do is you want to start thinking of an airplane kind of as multiple parts put together, okay? And the purpose, the whole goal, hopefully, if I do this right, is y'all guys will be able to look at an airplane and start being able to decipher, okay, well, those are the wings, that's the tail section, that's the empennage, you know, this is the fuselage, these are the engines, and everything kind of functions as its own independent. Everything's got a reason for why it's built the way it is. So these wings have the shape that they're in generally because they're designed for a purpose. Your rear part right here, known as the empennage, is going to have a specific purpose in mind. Your fuselage is going to have the shape that it has in mind. You remember the Super Guppy from yesterday that I showed y'all, right? It was big, it was wide, well, it was built with a purpose in mind. Even the engines that they put on it are going to have. And what do you think is the thought process that they put into it when they design engines or put an engine on an airplane? Why doesn't everything come with a jet engine?
What's that?
Why doesn't everything come with a jet engine?
Economics, fuel consumption.
Okay, fuel consumption.
Turboprops are much more efficient.
Okay, turboprops are much more efficient over.
Over jet turbines.
Okay, well you
That's
basically.
the C-130 still
Okay, well basically you have different types of power plants you can use. You got the piston engine, and then you got a turbine, and then you got a piston with a turbo on it. But yeah, economics plays into a factor of it. So, like, when you say economics, what do you mean by economics?
Well, just mainly fuel consumption, and if they want to make a cheap, like, plane for mass production, like the Japanese did in World War II with the Zero, then you'd want a cheaper engine, cheaper parts and stuff, and not want to pay much money on it.
Okay, so mass production. You know, why build one expensive turbine when we can build, you know, one big airplane with one big turbine on it when we can build 4 little airplanes with 4 piston engines on there, you know? So then you got 4 planes up in the air instead of one big target. Okay, so economics, like fuel, for example, and fuel can come up to a lot of things. Maybe you just physically can't get fuel where you're at, you know?
What how much fuel that Super Guppy takes?
Probably a lot. I mean, I don't know what the exact numbers on it are, but it probably takes a lot of fuel. But those are some considerations that you run into. Also, the weight of the fuel is a big thing. Now, if you having to deal with what we call self-loading baggage, or maybe cargo in general, for every pound of fuel that you have to carry, that's a pound of fuel that you can't, or that's a pound of revenue carrying passengers or revenue baggage that you can't carry. So you'd rather carry a pound of cargo versus a pound of fuel that you're going to burn off anyway. So you start playing into little factors like that, where you start having to balance the fuel load out with the cargo, and then you're like, okay, well, a turboprop's more efficient because it's not going to suck up the fuel that a turbine will. Maybe a turboprop's going to suit the mission better than a turbine will, or maybe a turbine's going to suit the mission better than a turboprop will. Okay, but anyway, so economics could be a lot of it. Economics plays, and then maybe they need speed. Maybe they're operating in an environment where a turboprop's just not going to be able to do it, or a piston's not going to be able to do it, so they're going to put a turbine on there. One engine can't do it, so we'll put two. Well, two can't do it, so we'll put four. Four can't do it, so we'll put six. Well, man, six isn't going to do it. Well, then we need a better engine. Bigger. There's something that goes bigger, stronger, faster. They're always improving the technology. But then, you build something bigger and stronger and faster, and then what happens? It costs more. So you wind up having one unit. A lot of the aircraft nowadays, what do you think is a common metal that they build aircraft out of?
Aluminum.
Okay, why aluminum?
Light.
Abundant.
Okay, it's light, it's abundant. Well, it is abundant. You wouldn't think that based on the cost of it, but yeah, it is probably one of the most abundant metals. But yes, it's aluminum because it's lightweight. Why don't they use steel?
Feels too heavy.
It's right, exactly. So why don't they use steel? Why don't they use iron? Okay, well, what's better than aluminum?
Titanium.
Okay, they use titanium, right? But why isn't everything built out of titanium?
It's rare and it's really expensive.
It's rare and it's expensive. Well, it is expensive. A lot of expense comes from the manufacturing cost, because to weld titanium, you got to be in a room that's purged of gas and filled with argon, and that's one of the things that's one of the things about titanium. So a lot of people just don't have the infrastructure in place to. Well, it's an inert gas basically, so they don't have the infrastructure to. They don't have the infrastructure basically, and titanium actually I think that's magnesium. But anyway, you start running into like these little really exotic precious metals and these hybrids. Now the big thing that they're coming out right now is this, they're using composite materials when they're building aircraft. Who knows what a composite is?
It's a blend between metals.
Composite is basically a blend, but yeah, go ahead.
It's like if you take, like for an example, a hockey stick, an old one's just wood, but the new composite ones,
Mm-hmm.
I forget what's the core, but it's carbon fiber reinforced,
Mhm.
so it might still be wood on the inside, but there's carbon fiber wrapped around it,
Mm-hmm.
just to give it a little more strength. So if you take two strong metals, the likelihood is that they'll be stronger if you use them to reinforce each other than if you just take that one metal.
Okay, you're pretty close, and you're right. Basically what a composite is, it's just basically a composition of different materials. But you generally, like most of your composites that you'll use, it's a composition of fiber and carbon, which carbon fiber. But generally what you'll have is they'll use fiberglass. And then fiberglass is one of the big ones that they'll use, and then they'll put like a carbon fiber overlay on it, or sometimes they'll put the carbon fiber underneath it on top of the fiberglass to give it its strength. So you have the high strength, but you have the weight savings associated with that as if you're using a weaker metal. And another thing about the composite materials is that you can put them together and it's a seamless design. So on a typical like aluminum aircraft where you'll have the seams where like the wings meet the fuselage, you'll have the rivets or whatnot, that all adds up to drag. A lot of your aircraft nowadays are coming out with composite materials where it's all just one piece. So the wings smoothly blends into the fuselage, smoothly blends into the empennage. I mean, it's all one eloquent flowing piece of technology, which is very great, except when
Something breaks.
Exactly, when reality hits. Because, it looks great when it's sitting out on the tarmac, but these planes are going to be used, people are going to bump into them, and the costs start to skyrocket. So, so economics really does play a big thing into it, because, why use one really expensive carbon fiber majesty of an airplane when you can use 4 aluminum airplane that just get the job done? You know, so you start really having to balance it out. But okay, so these are the things I want you to start thinking of. This is kind of the mindset I want you to get into when we start thinking about airplanes, especially when we start touching into systems, because everything is there for a reason. Everything starts working the way it does for a reason. So any questions about this? Yes, no, maybe? Okay. All right, so, well, we talked about, how's y'all's day anyway? Pretty good?
Good.
Kind of, sort of, anybody do anything
Friday.
interesting? Anybody? So what does that mean? So what, y'all,
No CCQ.
what's ECQ?
That's like
It's called quarters.
Like study time.
You have
Like
to sit
time
in
to
your
do your
room.
homework.
Sit in your room, you can't go to sleep.
Yeah, well, that's
Other
what
than
wall
that,
walkers
it's
are for,
Friday.
right?
You basically can't do anything except for sit in your room and look at your homework for like 2 hours.
Right, I'm sure y'all guys sit in your room and look at your homework,
I
right?
do.
Okay.
I do it until it's done and then
He catches on fast.
So I'm not gonna lie, I do all my homework already.
Well, that's good, guys. Y'all should study. Learn everything. Okay.
besides I'm
Realization
so much
hits
to
me.
get ahead my homework this year.
Well, this is the part where you'll start taking notes. So go ahead and bust out with your paper, and we'll start going into it. Okay.
How's there a fair plane that's like, that like composite stuff like that? Let's say, I mean, let's say cracking it, whatever, they have to weld it and then.
They generally patch it. They can patch it. From what I've seen, they'll patch it. But yeah, it's not something you really want to deal with. What's going on? You want to get some water?
Yeah.
Downstairs first? Yeah, okay, go ahead. Okay, yeah, go ahead. Just make it quick, because we don't have much time to begin with, so everybody starts leaving for water breaks. Man, it just seems like y'all just barely got in here, and now it's already almost time for y'all to leave. Okay,
30 minutes, or whatever you use.
okay, are all your classes 15 minutes, or what?
50?
They're usually 45 minutes.
Really? Man, you can't teach anything in 45 minutes. It takes me 15 minutes of monologuing just to get fired up, so. Okay,
How much
Well-
longer do we have?
huh?
How much longer do we have in here?
We got about 30 minutes. Yeah, so let's go ahead and take some notes, because we're going to be going over a lot of material. A lot of material. Yeah, I know. Well, I don't want to do a lot of things, but here we are. Okay.